Well, welcome. My name is Paul Reed. I'm one of the product managers in our AWS Boston office. And I'm here with Prash, one of my colleagues in Boston, and Lance, one of our customers, to talk to you about files in AWS. So for anybody who's been to any of our storage sessions at re:Invent so far, you may have seen this slide. It's sort of our portfolio slide, showing you the breadth of our storage services and some of the solutions we have. So we break storage down into three segments: block, file, and object. We obviously have EBS, EFS, S3, and Glacier that fill those. Today we're going to talk about EFS. We're going to talk about storage gateway. We're going to talk about a new feature of EFS file sync, which all help you perform files and store files within AWS. So as most of you are aware, file storage has been around for a while. It's very common. It's the thing that most people think of as storage. Why do we like it? We like it because it has an interface that's common. It has interfaces that have been around for years, and there are arguably millions, if not billions, of applications that talk to file systems and talk to files in order to store and retrieve data. It has some interesting semantics that are different to block and object store. It has strong consistency. It has things like locking. It has a hierarchical data structure in directories and folders. And it has a permissioning model that many applications have come to rely on. Many OSs rely on these. Many organizations rely on them for data protection, access control, and those sorts of things. So why is file storage so hard if it's so prevalent? So it's hard for administrators. You've got to estimate demand, buy storage, procure the hardware, build infrastructure, set things up, manage a lot of infrastructure. And once you get it set up, you've got to then do ongoing monitoring. You have to forecast demand, buy more hardware, add more infrastructure into your environment that has to be managed, secured, and controlled. It's quite inflexible in today's world. So today, in this session, we're going to talk about two things, and then we're going to let Lance come up and talk about how he's using AWS storage services. First, we're going to talk about hybrid use cases for files. So storage in AWS that's accessed from your premises, from your data center, backed by AWS storage. We're going to talk about EFS, file storage in the cloud for in-cloud use. And then, as I say, Lance is going to come up from Celgene and talk about how he's using some of these services in his environment and some of the things he's doing with AWS file services. So a very common use case that most people are used to, they see Microsoft file systems. They read and write from them, and they don't really think about it. It's shared drives, it's S drives, or those sorts of things. And for anybody that's in this space on the administrative side, you've deployed a lot of infrastructure in order to support these users over the years. You've built it up. As storage has run out, you've bought yet another storage array, or you've bought yet another server to manage the infrastructure needed to support these Microsoft Windows users. So what's the alternative from AWS? And I've heard about this storage gateway thing. How does that play into this? So storage gateway provides a way of deploying Microsoft Windows file services without having so much infrastructure. We do that through our volume gateway, our iSCSI block storage offering. So what storage gateway volumes provide is the ability to have block storage backed by S3, available as an iSCSI LAN to your upstream application server, your Windows server in this case. The gateway is deployed on premises in your environment as a VM. We support VMware and Microsoft Hyper-V. It performs both the protocol transformation from iSCSI into what's needed to get the data into S3, compresses data, performs some data transfer optimization, and allows surfacing up to 32 terabyte LAN, so about a petabyte per gateway. You can obviously deploy more than one gateway if you have a need for more than a petabyte of storage. And we allow a thin and a thick provisioning model. So you don't need a petabyte of storage on-prem to have access to a petabyte of storage in the cloud. You can deploy as little as a couple of hundred gigabytes of storage on premises, giving you access to a petabyte of storage in the cloud. Storage gateway volumes integrate with EBS, so we allow you to create snapshots of your on-premises volumes that become first-class EBS snapshots that you can create an EBS volume from and attach to an EC2 instance in cloud. Or you can use the same snapshots to restore data or bring data back to your on-premises environment via storage gateway as well. How does this fit into a Windows environment? So in a Windows world, you'd connect your Windows server to Storage Gateway. Storage Gateway would present LUNs to your Windows server. Your users would connect to your Windows server as they do today. Many customers who have adopted this model have slid Storage Gateway in entirely transparently to their users. They've moved from a fully provisioned on-premises model and replaced existing SAN storage on-prem with cloud storage, and their users knew nothing about it. In this mode, Storage Gateway moves the data into S3, and as I mentioned earlier, we allow you to create EBS snapshots. We have some customers that use the fact that those EBS snapshots can be surfaced to an EC2 instance to do file restores in cloud or to do disaster recovery in cloud by connecting those EBS volumes created from the snapshot of their on-premises volume to an EC2 instance running Windows. Same volume just moves between their data center and the cloud. Some of our customers have built quite elaborate, quite complex architectures with this, using some of the capabilities that Microsoft Windows Server provides with things like DFS. In this example, we have a customer, a large multinational media company, who in their primary data center on the West Coast, they have a cluster of Microsoft servers connected to a pair of storage gateways. They're running DFS across those. That moves the data into the US West 1 region. They then use DFS-DR to mirror that data over to an in-cloud Windows instance running on the East Coast, which is also attached to an EC2-based storage gateway, providing them a third copy of those volumes on the East Coast. So they have 3 copies of the data stored several thousand miles apart, giving them both local redundancy and local failover through things like DFS, and geographic redundancy of storage. Another mode that many of you might have heard is File Gateway. We launched that last year at reInvent. With File Gateway, we have customers doing a number of different things. One is just plain using S3 as storage, as file storage. Another is using File Gateway to distribute content around multiple branch offices. And the third is using it as a way of getting data into S3 for upstream processing with some of our native AWS data analytics tools that work against S3 storage. Similar to Volume Gateway, Storage Gateway deploys as a VM into your data center. It provides an NFS mount point that stores files as objects in your S3 bucket. So it's a one-to-one mapping between files and objects. Metadata for the file system is stored in S3, so it's entirely durably stored with the data itself. And we give you full control over how you access the data from an NFS side and how you store the data in S3. So just to go over some of those again, here's this one-to-one mapping. Now what this is really, really useful for is you have the same namespace for your file-based applications as you do for your object-based applications. Secondly, because we're storing files as objects one-to-one with no obfuscation of the data, you see a namespace in S3 that is natively accessible to the S3 capabilities. So you could write a lifecycle policy based on your file namespace to move objects down to either standard infrequent access or to Glacier. Or you could tag objects based on the namespace. So because the namespace is common to you, you can use all of the S3 capabilities natively. Again, I'll show you some examples of what customers are doing with this in future slides. We give you full control over how you access the data, lots of different NFS options surfaced on a per bucket basis, and lots of options for how you want your data stored in S3, from giving you individual IAM control over access to each bucket, things like storage class management, encryption with KMS, and something we launched last week, which is the ability to put guest MIME types onto objects if you're then taking those objects and potentially distributing them through CloudFront, because they're web assets that you want to expose on a website. Inside the gateway, how do we provide a file system on top of S3 when it's potentially down a thin network connection from your data center? We have both a data cache and a metadata cache. The metadata cache gives you that quick responsiveness to file system operations that you'd expect with a file system. So your applications, again, think they're working with a native file system, even though it's really stored off in S3. If you make changes to your S3 bucket outside of the gateway, you can tell the gateway to just validate its cache against S3 by calling a refresh cache API. And a new feature that we launched last week that, again, helps some of these automated workloads in cloud is the ability to trigger CloudWatch events when objects are made available in S3. So the gateway provides a cache, so it provides when you write data to it, the write is act by the gateway and then asynchronously uploaded to S3. But if you have an in-cloud workload that needs to know that data is there, because it's going to process it, you want to know when the data arrives. So we emit a CloudWatch event, and that you can then hook an application Lambda function or directly to your application. So how do those features help us? So again, here's a customer who has their primary headquarters in Los Angeles, and they want to use File Gateway to do content distribution where all of their content is durably stored in S3. So in this instance, they have a File Gateway in their headquarters in LA that uploads data into S3. They have 2 regional offices that are looking at the same bucket. They have a read-only view of that bucket through, again, a File Gateway. So all of their users think of their data through a file-based interface. When they write data to the gateway, it starts to get uploaded automatically to S3. They then ask to receive an upload notification. That upload notification, once the data is uploaded, gets sent via CloudWatch. They then hook that CloudWatch event through a very simple Lambda function to call refresh cache, which makes those files that they wrote in LA available to their branch offices in New York and Miami. We have another company that's doing something very similar. In this case, this is a call center application where they have a global call center that runs out of LA and Sydney to give them 24/7 call center. And in this instance, they want call logs from a call made in LA to be available to their operators down in their Sydney office. And as I mentioned, the gateway is just putting files into S3 as objects. So you can enable cross-region replication on that bucket to replicate all those objects over to another bucket down in Sydney. And again, they've now got this interesting geographic separation of that data. And there they have another gateway that's giving them access to that second bucket, which gives them a view of that bucket to the call center application down in Sydney. We heard a lot this morning in the keynote about machine learning and data analytics. And again, because the file gateway is just providing you a way of getting data into S3, so files and objects, or mapping from files to objects, all of the capabilities, all the analytic capabilities, things like Athena, Lambda, recognition, can act upon those objects in S3. And with things like the CloudWatch events and refresh cache API, you can start to automate workflows that span between your file-based applications and your object-based analysis. The other thing that we have a lot of customers doing is they say, well, I have a lot of data that I want to put in S3, but I don't have enough bandwidth to move it. So we have one of our customers, Halliburton, is using Snowball to load data into S3. So they're moving objects, they're using the file interface to write files to S3, which then get put into their S3 bucket. And they're then using the file gateway to provide online access to that data. So they have the data, they want to move it in S3, but they don't want to lose access to it as files. Now, the interesting thing here is that both File Gateway and Snowball Edge use the same metadata format for storing files. So the files that they wrote to the Snowball with all of their metadata land in S3 and then are made available back to them through File Gateway with all of the same file system metadata, the same file namespace and all of the usual POSIX permissions that you'd expect. So those are some of the things we're doing in the hybrid space, using File Gateway and Volume Gateway to provide you online access to AWS storage. I'm going to hand over to Prash, who's going to talk about EFS and how in-cloud workloads can use files.
Great. Thanks, Paul. So let's talk about how you can run in-cloud workloads with file storage using the Amazon Elastic File System. So first, before we talk about EFS itself, let's talk about how you would do file storage yourself prior to EFS. So you would actually set up file servers to run your NFS file serving. You would attach a bunch of storage volumes to actually store the underlying file data. And then you might want multi-AZ availability and durability, so you might actually set up multiple file servers across multiple availability zones and establish replication across those two file servers. And then you might also have to manage failover between them and set up appropriate mounts across all of your clients. So basically, to summarize, it's a huge pain to actually set up, maintain, manage your own file storage. So to address this whole set of pain points around setting up and managing, provisioning storage based on your capacity expectations, and then needing to re-provision based on storage changes and things like that. We actually launched Amazon EFS about a year and a half back. And what Amazon EFS is a fully managed file service that provides you a way to create file systems in a very simple way in a matter of minutes, and then to basically not have to worry about any of the file serving infrastructure itself. All of the file serving infrastructure is fully managed by the service. Everything from setup and management to actually taking care of the capacity itself. Your capacity actually grows elastically. So you don't need to worry about provisioning a certain amount of storage capacity up front. All you do is start using your applications and add data, modify data, delete data as the applications proceed. And the storage itself elastically grows and shrinks as your usage changes. And Amazon EFS is also built to be scalable in the sense that as your storage scales up, your performance also scales up. So you don't need to worry about, will I get the appropriate performance depending on the amount of storage capacity I have. And it's also scalable in the sense that it's shareable across not just a few clients, but across up to thousands of client instances of EC2 instances. And another aspect of the simplicity of EFS itself is it exports the file storage as an NFS accessible file system. So you can actually use the standard NFS protocol. You can basically use any Linux EC2 instance that has NFS clients installed, which is default in all modern Linux distributions. And you get to use your file system in a very simple way. And then, of course, Amazon EFS is built to be highly available and durable. And the data itself is redundantly stored across multiple availability zones. And you don't need to worry about making sure that you are protected against component failures, failovers, and things like that. So in essence, it provides you a very simple, elastic, and scalable file system that you just create in a matter of minutes and use from your applications and not have to worry about any of the management complexities. EFS is designed for a wide spectrum of application needs. So it really targets the workloads across an entire spectrum, starting from low latency and serial I/O intensive applications on one side, things like developer tooling, home directories, container storage, all the way up on the other end to scale out jobs that require very high levels of throughput and parallel IOPS and so on. Workloads like big data and analytics, media and entertainment workflows, and so on. And then in the middle, there's all kinds of applications, everything from web serving and content management to enterprise workloads and database backups and messaging and so on. So it really is targeted at a very wide variety of applications, no matter what the specific performance needs are. And these are some examples of EFS customers across this entire variety of use case scenarios that are using EFS today. So in terms of the security model itself, EFS actually provides multiple layers of security. So you can actually control the network traffic that goes back and forth between your EC2 instances that are mounting the file system itself and the actual file system using VPC security groups and network ACLs. You can actually control individual file and directory level access using POSIX permissions, which is what file workloads in general are used to from decades, as Paul mentioned. And then you can control administrative access to your file system, the API access to your file system using AWS IAM, and you can do both resource level and action level permissions. And then you can also, recently we launched support for encryption of data at rest. So you can actually use keys managed in AWS KMS to encrypt all of your data at rest. And again, here the model is very simple. You don't need to worry about actually encrypting and decrypting the data. You just set it all up, and the service itself takes care of all of the encryption in the backend. So let's talk about how you can actually use Amazon EFS and how it looks to your clients. So the EFS file system itself is a hierarchical directory structure as you would use any file system. And then that is presented as a set of mount targets, which are basically endpoints in each of your availability zones within a given VPC that you have configured. And then there's a common DNS name that appropriately maps to a mount target depending on which AZ you're using the DNS name from. And all you need to do is, from your NFS clients, from your EC2 instances themselves, you just issue a simple mount command as you would any NFS file system. You point the mount command at that DNS name. And once the file system itself is mounted, your applications get to use the files and directories as if they're using any other files and directories. So as I mentioned, it's designed for a wide variety of applications and workloads. The way it enables you to use the same service across a wide range of workloads is basically by providing two performance modes. We provide general purpose performance mode and the max IO performance mode. The general purpose performance mode is the default one, and that's really what we recommend for the vast majority of applications out there, applications that are latency sensitive and just general purpose in nature. And then the advantage there is you actually get the lowest latencies for individual file operations. But then the trade-off there is there's a limit of up to 7,000 operations per second that you can perform per file system. And this really is the best choice for most workloads because we have found that most customers find this to be the happy spot. And then we also provide another performance mode called the max IO performance mode, in which you can actually achieve larger scale of throughput and IOPS, and you use this generally for large-scale analytics applications, data-heavy applications, and so on. And here you actually get virtually unlimited ability to scale out throughput or IOPS. There's no specified limit, as in the other case, with the trade-off of slightly higher per operation latencies, which usually does not matter for massively parallel applications that tend to use this performance mode. In terms of the data storage itself, EFS actually distributes the data across an unconstrained number of servers across multiple availability zones. And this design really helps avoid the bottlenecks that are a result of traditional file server designs. And it enables very high levels of aggregate IOPS and throughput because of this design of unconstrained number of servers. And then the distribution of the data across multiple availability zones is also what enables the high availability and durability that EFS is able to offer. So an implication of this highly distributed data storage design is that the per operation latency impacts your the IO size leading to the throughput. So basically, the smaller the IO size, the smaller the throughput, and the higher the IO size, the higher the throughput you can achieve at the same IOPS level, essentially. And so as far as possible, whenever possible within your application scenarios, we recommend that you actually use higher IO sizes for your applications. In order to take advantage of the distributed architecture itself, another thing we recommend is that you parallelize as far as possible. So if there's ability for you to increase the number of threads, maybe even scale out in terms of the number of instances from which you're running your workloads and so on, you can actually achieve higher level of scale in terms of IOPS and throughput. So let's talk about the economics itself. There's actually no minimum commitments or upfront fees, as I mentioned. There's no need to provision a given amount of storage in advance. And there's no other fees other than the storage dimension itself. There's no other billing dimensions. And the prices we share here for the various regions that EFS is available in. And just to dive in a little more into the economics itself, if you were to go back to the very first slide I showed you about the do-it-yourself file storage, you would have to worry about paying for the EC2 instances themselves that are running the file servers. You would have to worry about paying for the EBS volumes that are attached to the servers themselves. And then you would have to also worry about the costs regarding the inter-AZ data transfer, because you're actually establishing replication across multiple availability zones. And then with EFS, here we show you an example of, suppose you're storing a 500 gigabyte file system. You can actually see that EFS is about 70% less than the do-it-yourself solution. Once you add up the storage costs themselves, the compute costs, and the inter-AZ data transfer costs, you see that there's a significant, cost savings in terms of using EFS. And finally, I'd like to share some best practices with you in terms of Amazon EFS usage. So we recommend that you test your application using actual workflows before you actually take them into production, because for example, you would want to select the appropriate performance mode. And just to recap, we recommend general purpose mode for the lowest latency and max I/O for scale out. We recommend that you use a more recent Linux kernel version, Linux kernel 4.0 or newer, and that you mount via NFS version 4.1. EFS supports both NFS versions 4.0 and 4.1, but we recommend the use of version 4.1 for optimized performance. And then to optimize, as I said, we recommend that you look for opportunities to aggregate the I/O and increase I/O size, perform asynchronous operations when possible, parallelize as far as possible, and then use client-side caching whenever possible within your application scenario. And then there's an EFS bursting model that I didn't go into here, but we shared the details of that more in the documentation. And in general, we recommend that you monitor your burst credit balance and things like that using the CloudWatch metrics that EFS emits. So I would like to pass it back to Paul to talk about the EFS file sync that was released recently. Thank you.
Thanks, Prash. EFS, very awesome service, and as Prash showed, the TCO is significantly better than rolling your own, and a lot of those headaches of managing your own file system just go away. So how do you get on board? And one of the things that we've seen since we launched EFS is that customers want to run their file-based applications in EC2. They want to use EFS, but they've struggled to get their data into EFS. So traditional Linux-based copy tools, they don't have parallelism. Let's flip to this. They don't have parallelism. They don't necessarily traverse modern networks from your corporate network into AWS easily. You have to suffer things like latency and packet loss. You have to manage and monitor the transfer to move a whole file system into EFS, make sure you don't lose any data, make sure the data copies over before you can decommission the data on-prem and fire up your application in cloud. So it's not simple to move a file system from one place to another. So in order to help customers move to EFS, we've created a new feature of EFS called EFS File Sync, which creates a simple and fast way of moving your data from an existing file system into EFS. So we do this by deploying an agent on-prem that accesses your local file system. It outbounds connects over port 443, so it's secured as soon as it leaves your data center, all the way into AWS, and writes into your EFS file system. It's about 5 times faster than using standard Linux copy tools. If you go back to one of Prash's slides, he said parallelize, parallelize, parallelize. Can't say that quickly 3 times. And so we use massive parallelization to move data as quickly as we can over the network into your VPC and into your EFS file system. We take care of provisioning all of the infrastructure to traverse networks from your data center into EFS, straight into your VPC. The 3 main use cases that we're targeting for this. One is obviously on-prem migration into AWS, into EFS. The other is we have a number of customers, as Prash mentioned, that have built their own shared file systems inside AWS rather, and want to move to EFS to get rid of some of those management and provisioning headaches, even in the cloud. So we provide a way of moving that data out of your roll your own in-cloud file system into EFS. And the last use case that we're targeting here is customers who have data in one EFS file system in one region, and maybe they want to consolidate into another region. So we even support EFS to EFS cross-region. I'm going to hand over now to Lance Smith from Celgene, who is going to talk about how some of our customers are using some of these services, EFS and Storage Gateway, in the wild. Lance.
Thank you, Paul. Good afternoon. My name is Lance Smith. I'm from Celgene. Real quick, what I'm going to talk about today, quickly about our company, our cloud journey, some of our use cases that we use EFS for, and then some of our hybrid workloads that we've been using the Amazon Gateway. Celgene, we're a pharmaceutical company specializing in cancer and immunology. New novel discoveries, we are truly trying to save the world here. We cover our R&D, manufacturing, sales. We have about 7,000 people in 70 sites around the world, and that has a huge impact on how we architect our applications, especially running in the cloud. Our CMDB has about 800 applications, 600 of which we deem critical. We are a COTS shop. 500 of those have been purchased off the shelf, and about 100 are in-house. And when we try to migrate COTS applications, it does have a challenge for us in that we cannot modify these applications. Our journey, we started in AWS around 2014, and like many companies, we started very simply, EC2 and S3, kind of started dabbling, got a little bit more comfortable, went RDS, and 2015, R&D became very, very comfortable, and they had an enormous demand for massive performance of massive files. We went all in, multiple direct connects, 310 gig direct connects, networking all around the world. And just because of that networking now, our development teams are starting to go much more into serverless design. So we're now doing EMR and workspaces, doing much more Lambda, and now we're starting to work with IoT, primarily because of our direct connect. And interesting enough, our use of storage is allowing us to migrate more and more into Amazon because of the storage features of AWS. We have three major categories, at least for this discussion, about the applications that we put in the cloud. Our genomics HPC workloads. These are big I/O, petabyte scale workloads. When we do the number crunching, we launch about at least 5,000 instances. That's anywhere between 75,000 and 150,000 cores to process the data. We also have chemistry type jobs, much smaller I/O. So we often use GP, general purpose EFS for these workloads. A few gigabytes per file can translate still into tens of thousands of core hours for each individual job. Another category, we have collaborations with universities and hospitals. And this does include some of the genomics and chemistry type workloads. However, because of the data, the intellectual property, and allowing outside entities with our data, we do put these in a separate category. We also have some corporate workloads, email, file print, et cetera. Salesforce.com, and those are what we call corporate. And legacy applications, another 500 applications. We're working with Amazon Pro Services right now to assess each individual application so we can start migrating as soon as maybe next year. For the rest of this talk, I'm just going to talk about those top three, and that's really the really meat for the complicated migrations that we've been doing. So for our legacy applications, we have 500 COTS applications. We really want to move them to the cloud, but we cannot modify them. And it puts huge challenges on us, but there are some things that we really care about that are truly important to us. The most important thing is data protection. We are working on cures for cancer. Intellectual property is key. We are often willing to give up some availability for additional durability. What that means is, we can have a little bit of downtime, but we cannot lose that data. From file systems, we also care about, how much does it take to maintain. We are a very lean shop. Anything that we can do to minimize effort on part of IT, we'll definitely do. We're also a frugal company. If we can get the performance and save some money, that's definitely good for us. TCO, so a lot of applications or use cases on Amazon cost a certain amount, but there's other licensing, et cetera, that we need to bake into the cost. And consistency of business processes. We are here for the scientists. Celgene does not exist for IT. What can we do to help our scientists? But we can't. It's not our job to tell them how they should work. They should tell us how they want to work. Best practices, key for us. This has implications for us on how we do things in AWS. But we definitely want to design for failure. We don't want to lose data. Part of that is separating compute from storage. And that's to IT, that's a very new concept. On-premise, we have file servers, we have Windows file shares and NetApps, and the data is on the server itself. Moving to the cloud, we can now separate that out. Reducing manual effort, of course, and don't DIY file systems. And Prashant was talking about that. We absolutely definitely do that. And by using EFS and some of the other services, we can move applications into the cloud without having to do the refactoring work to make that work. So EFS came out. We've been clamoring it forever. And when it came out, when it went GA, we were completely excited. But for the first workloads that we started moving, a lot of HPC applications, almost every single application that we have doesn't speak block, or doesn't speak object. It wants block storage. And this is perfect for that. It's fast. It has all the performance that we need. And it allows us to move more and more applications because of the services that provide block storage. Why EFS? It's simple. It just works. There's really no magic to it, at least from a customer point of view. You go in, you create the file system, you mount it, and wow, it's done. You don't have to do anything. There's no patching of servers. In some regions where we don't have EFS, we still have to maintain EC2 instances that serve out NFS, and oh my gosh, that's such a pain. And we don't have to re-engineer applications. Like I said, we have 500 apps, and we cannot modify them. And we do love S3, and not to belabor that, but we put petabytes in S3, but the vast majority of applications do not speak object, and EFS really helps us for those legacy workloads that we have. So this is a quick little schematic of one of our applications. In historic old days, we'd run this on-premise. We moved it to the cloud before EFS went GA. And with those workloads, we had a little NFS server, and it was stable. We didn't particularly want to run our own NFS server, but it's part of the game that we do, so fine. Our other options were to run a parallel file system. If you were at reInvent 2013, I think there were a few talks about how to run your own parallel file system across 10 or 20 nodes. We definitely weren't going to do that. Talking to the vendor of this particular software, this software is very, very expensive. It's upper 5 figures per person or per user per year. And they had a SaaS offering, and when we first heard about it, very excited. Let's do that. And then they wanted 4 times what we were paying already, so that wasn't going to fly. So now we switched to EFS, at least for the regions that have it. Works great. We were able to shut down the NFS boxes, save some money, have better performance. And interestingly enough, we doubled performance on per node basis by switching to EFS, and we saved a lot more money. And my admins don't have to deal with the problem. And we don't have, oh, an NFS server locked up again, go fix it. Now, this was a very, very complicated application, probably a little bit more challenging than we originally thought. So we really want to thank the Amazon HPC team that helped us out. If you are stuck with an application, there's a tip. Call your Amazon rep. They will put you in touch with someone that can help you out. Another workload that we have, this is, originally we bought this from another company, and it was pure cloud native. That's ideally what we want. However, we want to integrate these with old binaries that we have, custom scripts that we ran. So this has now become a semi-legacy, semi-cloud native application. So the pipeline starts up. It's all object aware. Petabytes of data come in. And then as our binaries start kicking on later down the process, we start switching more over to block storage. That's where EFS comes in. And we like I said, in the regions where we don't have EFS, we run NFS on the EC2, and well, we have to support that. Here's another application that we have here, also part cloud native, part block. We start in, and what the application does is we do a lot of collaboration with universities and hospitals. We all share data together to create, cures, to find new cures. The data itself comes in often via object. And then universities, they upload their binaries. But a lot of entities out there are still not object aware. And they send us their scripts or their binaries or the application that they wrote. And they integrate that with our data in order to find new cures for us. This is a circuit view of how we have our networking, and this has implications to how we access our storage. So, even though we have EFS in the cloud, sometimes we need to upload new binaries. Sometimes we have files on premise that we want to copy. So we have really, really big direct connects. I think as a company, we have 4 10 gig direct connects and a 300 meg link. So we can mount EFS from our network. We don't open files. We just primarily one-way copy. And I think I have some, how that networking is done there. Switching a little bit to hybrid cloud using the gateways. So we have a number of sites. Like I said, we have 70 sites around the world. And some of those are primarily R&D sites. And at all those R&D sites, we have hundreds of instruments. And each one of these instruments has a PC generating massive amounts of data. We think between all of our sites, we have about 1,000 instruments and at least over a petabyte of data all around the world. And we really, really wanted to centralize these in S3 buckets. However, of those 1,000 instruments, there are approximately, we think, around 300 unique systems. And we cannot change the application. But we want to take that data, move it to the cloud so we can do additional analytics. So how do we do that? We cannot modify the system. We even have some, no Windows 95 anymore, but mostly Windows 7 and up now. We do have some 2000 here and there. But how do we get those systems to upload to the cloud? And that's really, really difficult, and that's where the gateway comes in. We also want to archive data. We have a lot of stale file shares. Projects have finished. There's a server sitting there, but no one really uses it anymore. Let's move it off-premise, move it to the cloud, cheaper storage. And then also for data migrations, we have a lot of applications that are soon to be in flux or migrating shortly to the cloud. How do we move that data to the cloud in preparation for the next day when we do a cutover to the cloud version? Like I said, we're a COT shop. We have these huge challenges about how do we make these applications in the cloud without having to modify them. And like I said, it's really, really hard to change our people and the processes. We don't want to change them. We want them to, have a better scientific process. We did try a number of things. We had some ideas over the years to transfer data from these instruments and from our lab systems into the cloud. One of our first attempts was an S3 client. And we picked Cloudberry, CyberDuck. We put them on the instrument. Scientists, here you go. You have now infinite amount of storage. Copy your data. Yeah, that didn't work. Technically, it was fine. Technically, it was, if you're a cloud person, but trying to explain object storage to someone who's been doing, science for 20 years is really hard. And most IT people don't even know what object storage is, let alone, a layperson. We have another instrument that, it was so important. They were taking samples that could not be replaced. You get one sample, and it costs an enormous amount of money. And if they lose the data, it's gone. And that's it. So they wanted that backed up. And this was about 4 years ago. And the only option back then was no backup whatsoever, or the corporate platinum grade backup, which is what we do for servers. Right? So that means a Tivoli agent, data is copied to our data domains. It gets sent to our tape backup system. Those are sent to Iron Mountain. And for the quantity of data that they had, we had to give them a quote for $25,000 for one system. And they said yes, because they had to. And that's not the way IT should be. We should work with them. But at the time, we only had this platinum grade solution. And it's not an unfair cost. If you see what IT had to do to give that option, it's $25,000 was a fair price. But from their point of view, that wasn't acceptable. And they had 3 more of these instruments, and we did the same thing with those as well. So that's where, when the file gateway and storage gateway came out, we were really, really excited that we could deploy a much cheaper price point for archive for these application instruments, have the files accessible to other applications, Athena, EMR, and is at a much cheaper price point. So this is multiple workloads on one slide, so bear with me. So on the left-hand side, you see the lab, the wet experiments. Scientists generate data with the laboratory instrumentation, take pictures or whatever the instrument does. The PC takes the data, does some initial processing, sometimes all the processing, and either uses the file gateway, it directly drops it off into the bucket, and the instrument PC doesn't need to know what the cloud is. It doesn't have to have an S3 client. All it knows is there's an NFS share there, put it there, and boom, it goes in the cloud. We also have additional on-premise servers that for various reasons we don't want to modify. They're just the way it is. So they can write directly to EFS by mounting it over our Direct Connect. And then we also have a number of 3D rendering systems. So if you guys remember Minority Report with Tom Cruise, he's on stage waving his hand or all those images flying by. We don't look like Tom Cruise, but we have rooms that do something similar. So all the scientists put their goggles on, they go into this room, and they start diving into molecules to see how our compounds interact with cells or how proteins are folding to interact. And that system is on-premise, requires a lot of power, but our data is crunched in the cloud. So we can use a file gateway to transfer data back and forth without modifying either system. This is another networking viewpoint, or how we do the networking to the cloud, but without the circuit view. This is more of a cloud view of how it's done. So on the left-hand side, we have a number of data centers around the world. So I simplified it to just 2, but we really have a lot more than that. We have a bunch of subnets now. We have a lab compute subnetwork, research compute network, server subnet, user subnet, and the different subnets have different connectivity options into the cloud. They go to our routers, and then we have a public interface on a Direct Connect, and instead of using our normal internet connection, we can send that traffic up our Direct Connect and access S3. EFS traffic can now route over our Direct Connect on our VPC. Our EC2 clients can mount EFS without any modification. I cannot stress how much we love EFS. You just mount the darn thing and it works. So in summary, like I said, EFS is super simple. It's easy. You mount it and it works. It's scalable. In the old days, our scientists say, I need more storage. Please add more storage. Or the NFS server crashed. Please restart. We don't have any of that problems anymore. And Storage Gateway enables us to access a lot of the file services in the cloud without modifying the existing systems that we have. So I want to thank the Amazon Storage team, my account team, the Celgene HPC, and as well as the Amazon HPC team. Thank you.
Thank you very much. That's a lot of use cases there in a very short period of time. So you can breathe now. Just wanted to remind people that there are more sessions around storage. So if this wasn't enough or you'd like to look at a little more, there's a deep dive on EFS tomorrow. And we have another session tomorrow around migrating large data sets into the cloud. We've had some sessions earlier in the week that will be available on YouTube after the event. So catch those if those are of interest to you. And just a reminder that all of these sessions, if you're going for AWS certification, can be used for your certification. And thank you for attending, and we'll take questions.
Hey, Paul. My name is Dennis Kutriber, and I'm actually up the street from you, Novartis. So right on Main Street. So as you know, we're actually heavy consumers of data and generators of data in general. I think we have about 45 petabytes of data that lives mostly in Isilon today. We are in the cloud trying to consume more elastic file storage. So we have a multi-account strategy with over 200 accounts that are managed centrally. So a couple of questions around capabilities for EFS. So the first is CIFS and SMB support with Kerberos authentication. Is that on your roadmap?
Yeah, so So today, EFS actually exports file storage over the NFS version 4 and 4.1 protocols and primarily targets Linux EC2 instances being able to access EFS. Support for Windows clients to be able to access EFS file systems is something that we have heard a lot from customers about as being an important thing. And we are certainly considering that along with all of the other feature requests as part of our roadmap. But I'm not able to comment on the specific roadmap item.
Okay, so that's the first question. Sorry, I'm just going to make these really quick. So
sure.
Global DNS resolution namespace. That would be really useful if we can take the, so EFS DNS namespace is now global. So from a multi-account perspective, we would like to mount these EFS targets across hundreds of different EC2 instances spread across entire world, literally in basically regions and EC2 instances. That would be really useful.
Yeah, so today EFS file systems are accessible within a given region. And then the request that you're specifically pointing to is a very interesting one. We'll definitely take that into account. I think what that involves is basically being able to access, just to clarify what you're asking, you want to be able to access EFS file systems from across multiple VPCs or even multiple accounts and across regions.
Exactly, yeah.
Okay.
So have the ability to resolve that namespace globally from any VPC, from any account, just like for other public AWS services like Dynamo or RDS even, or S3.
Yeah, we'll definitely +1 that request.
Okay, 2 more quickly.
Sure.
EFS automated snapshots, so that's, most of the NFS type file systems like NetApp support that. Is this on your roadmap, snapshots?
Yes, so today we actually provide you a way to back up your file systems. We actually provide quick start guides to do backups, as well as you can use the recently launched EFS file sync to run regular backups. But if you're interested in getting a point-in-time snapshot as opposed to copying files across as a backup, that is something that we are again hearing from customers a lot about. And so definitely we'll +1 that request as well. Yes.
Next,
is there an easy way to do the archiving policy from the EFS to like Glacier?
Yeah, so we do see some customers actually use EFS in a way that they use EFS for a certain genre of data that they store, and then they actually offload that data onto S3 and then even use lifecycle policies beyond that to offload it to S3IA and Glacier and so on. That is a common use case today, but to do so, customers have been using their own tooling and scripting to actually offload the data from EFS to S3.
Lance, I thought I recall you talking about doing that. Do you have a way that you do that?
What was the question?
Yeah.
Archiving data out of EFS into, say, Glacier for longer term
Actually,
retention.
yeah, no, what we're doing there is when we do that, we just use a CLI and some scripts on the local EC2, and then just copy that to S3.
More questions?
Hey, is there any way that you can be sort of combine EFS with storage gateway, so you can kind of get the cost benefits of using S3, but also remove the reliance of your on-prem infrastructure by having a VM running on-prem with the storage gateway software installed?
So let me clarify. You're looking for sort of on-prem access to EFS or sort of via a cached model?
No, so with storage gateway, you have to have a VM running on-prem, right?
Yep.
So if you can instead have that running within your VPC using EFS, caching a set of files, 100 gigs or so, within that storage gateway, and shipping the rest off into S3.
Right, so we have a number of customers that do that today, and actually we provide, as part of the create gateway process, you can select Amazon EC2 as your host, spin up a storage gateway in cloud that is exposing your S3 buckets to your file-based applications. Different use case, obviously, there to EFS. You've got a single EC2 instance that's giving you access to that NFS file system, but your backend storage is S3. So if your dominant use is to have the data as objects stored in S3 because the majority of your applications are object-based, then we can give you that file-based access through the in-cloud gateway. I would say if your dominant use is file-based, EFS is the right solution to be using there just because of a lot of the benefits that Prash mentioned.
Especially if you're sharing it across
multiple VPCs, multiple instances. But yes, you can run file gateway in cloud today. Yeah.
Hi, I have a couple of questions. One is for your file gateway. Do you have locking for file locking when we're having concurrent writes from different sites, or how is it handled with storage gateway? That's one. And then second, you mentioned that you have snapshot capability for the storage gateway. Did I understand that correctly? And are those snapshots in the cloud, in the S3 buckets, or is it on the local machine VM that's running the storage gateway?
So two different questions, one about file, one about volume. First question about file, which I've forgotten already, is to do with file locking. So what the gateway provides today is a fully POSIX-compliant file system to all clients connected to the same gateway. If you have multiple gateways connected to the same bucket, our recommendation is that only one of them is writing to that bucket. So we provide the ability for secondary gateways to export the share as read-only. Again, we're sort of trying to provide a fully POSIX-compliant file system on top of an eventually consistent object store. So multiple writers can be a problem, as with any multiple writer situation direct to S3. For snapshots on volume gateway, the snapshots that you take of the volumes are EBS snapshots, so you can use them within EBS. And the snap is taken in cloud. Now, we manage the fact that data may be in flight at the time you request the snapshot. So the snapshot that you get is the view of the volume from the application's perspective at the time you request it. So if there's data in flight that hasn't made it from the gateway into the cloud and been persisted, we take care of making sure that data is included in the snapshot. So you sort of get the snapshot you would expect from a traditional file system, and we manage the fact that we're doing asynchronous uploads and moving data around under the covers. We actually covered that, again, just an infomercial. We covered that in our deep dive yesterday, so if you watch the YouTube, you'll see a fairly detailed description of how snapshotting on volume gateway works.
So can you speak to any of the differences between storage gateway and some of the hardware solutions that partners make, like a Veer and that kind of thing? Is there an advantage to using one of those partner solutions, or does storage gateway do everything I need?
This is AWS. We have a lot of partners that provide a lot of solutions, and there are benefits, pros and cons of each, right? For storage gateway, one of the things that we wanted to address for customers is this idea of native object access. And so we do this one-to-one mapping of files to objects. We don't do encryption. We don't do duplication. We want to enable native storage in S3. Many of our vendors that have a whole host of additional capabilities or other capabilities don't give you that native access to your data in S3. You go through their solution to get access to it, even once you're in cloud. And we felt like there was a need, and we heard from customers that there was a need for this native object access. I just want to use the gateway to get my data in there, and then I have a scalable storage infrastructure in S3. Why I don't want to build another storage fabric to get at it. So all solutions come, and again, it's going to depend on your specific use case, whether storage gateway or a vendor solution would be better for you. I'm more than happy to talk offline about your specifics.
So one of the reasons for us to be hesitate to use the EFS is that it seems like the support region is really limited comparing with many other the AWS service, like EBS, and is that any reason? So it's only supporting the limited region. Is there any plan to extend the support to most regions?
Sure. So today, Amazon EFS is available in 6 regions globally, and we definitely are looking to expand globally to all regions. And again, we are actively working on our roadmap, but I cannot share details of the roadmap, unfortunately, today.
I was wondering, are you using STMS at all at your facility, Celgene?
What was that question? What was STMS?
If you're using STMS, and are you linking it to the storage gateway?
Scientific management?
Yeah,
okay.
Data management.
Yes, we have on-premise LIMS and electronic lab notebooks, and that captures the high-level view of the scientific data. However, that does not capture the bulk data, and that's what we're missing, and that's what we're looking to do the gateways for.
Any more questions?
Actually, just looking at the clock here, I see we're out of time. More than happy to take questions in the hallway. Don't want to delay the following session. Thanks all for coming. And as I say, we'll make ourselves available for questions offline.
Thank you.